Let me just make this a bit smaller. Okay, so let's talk about speed. We were trying to talk about speed the other time. So let's talk about speed here. Because every time you see speed, for example, when we go back up here, let's see. 1 second. Data transfer. I think we talk about it here in this. Yeah, right here. When we look at the different data sizes, right? We said the speed is measured in bits per second. Okay, bits. That is data transfer. Data is transferred bits per second. So now let's look at the processor speed, right? The processor is the chip. Remember we talked about the chip in your computer, and the chip is the chip is the CPU, which is responsible for what it says are different. It says right here. Where is it? Let's keep going down. Okay. So right here it mentions basically this section here, right? If you look at this section here, it talks about complex instruction set. That is, the chip is responsible for lots and lots of instructions between the chip itself and the computer. A lot of activity that has to get completed. The chip is responsible for sending out those instructions. Okay, so let's see what exactly that means in terms of how the chip does that. The processing, how it processes, instructions. Okay, that's what we're talking about. How the chip processes instructions. Okay, let's see something else here.
Hey, Teo,
Yeah.
What chip are you talking about? Which chip?
Okay, well, you missed the last class.
Oh, the CPU chip?
Yes.
Okay, sorry.
So the chip, right? This is the CPU. Actually, the CPU, right, is literally the same thing as the chip.
Oh,
right?
Okay.
And the chip is right here. So look at a picture of it. On your computer, you might see different labels. 1 second, where am I in? Where am I here? Okay. So this is the chip right here. It looks like that. Right, you're gonna see it when you open up. Well, you may not actually see it. It's kind of like embedded inside. It's covered in your motherboard, right?
Yeah.
Or it might look like something like this here. There are all kinds of. Okay, right here, this might be the picture that you see in your motherboard.
Right.
Something like that, right? So that's actually the CPU. But a lot of people refer to your computer as this computer box,
Yeah.
as the CPU. So when you see a computer box like that, you might refer to it as this is my CPU. That's not technically the CPU. Technically, the CPU is the chip, right? It might be Intel or whatever it is, but that's actually the CPU. So what it's telling us here is It also refers to the CPU as the processor, right? It says right here that the role of the processor, right here. So the role of the central processing unit, CPU, is to control and direct all the activities of the computer, right? So the CPU might be referred to as the brain, but not because it thinks independently, it's just because of the very serious function that it does, right? So the processor, the CPU, the brain, it's talking about the same thing, all right? So it's referring to that chip that's installed on your computer. And we saw earlier that there are two different types of chip manufacturers down here. Where is it? I think it's down here. Sorry, give me 1 second. Let me find it again. The manufacturers. Okay, so you have AMD and you have Intel. Yeah, right here. So right here, processors are small chips. Okay, small chips consisting of an array of millions of transistors. Intel and AMD are two largest PC compatible CPU manufacturers, right? So their job is to process a lot of instructions, right? A lot of instructions back and forth, all the activities on your computer. All right, so let's keep going. So I want to look at, let me get this out of here. I want to look at the speed, right? Let's look at the speed here. So if you look at this section here, I'm trying to highlight. Okay, so the speed is calculated in hertz. You see right here, just like the rental car company, hertz. Electrical cycles per second. How many of those electrical cycles, it says right here, each time the internal clock of the processor completes a full cycle, a single hertz has passed. Right, so hertz is electrical cycles per second. Okay, now in terms of the speed, it says right here that the first PC ran at 4.77 megahertz, right, which is millions of cycles per second. So basically calculating millions of instructions every second. So right now, your computer processor is capable of processing 3.5 gigahertz, right? That's a lot of, that is millions and millions and millions of cycles per second. Alex, does that make sense? Are you getting that?
Yes.
So 3.5 gigahertz per second, right? It's faster. It's just getting faster and faster. Okay. Now, because of the speed, right, and all the work that the processor does, it tends to get hot. Right here. It tends to get hot. It says there's a lot of heat that is generated. Okay, heat. So it's possible for your computer, not even possible, your computer will get warm or even hot if it's not being cooled down. And it has internal coolers, as we're going to see later. So the speed is a lot of work that it does. Okay. So it's a good idea to take a note of the speed. And if you go back up here to look at the, should I say, specifications up here, right? You can see that, so let's see, we have the Intel chipset core, so it refers to the core there. Then we have the PCIe. That is your um, the various kind of expansion slots on your computer. We're going to look at the SATA connection. We talked about that a little bit. All right. So the Intel Core there, right? That is it supports the Intel Core processor, right there. So a lot of numbers, a lot of specs that we have to kind of be familiar with. Okay, but let's just keep going. All right, there's something else here we should mention, which is referred to as cache. This word is like cash, like money, cash, right? Some people say cachet, but it's actually cash, like CASH, cash. That's how you pronounce the word. Okay, so what does the cache do? Basically, right here it says that. Let me select here. Cache is a quick form of memory that speeds up the performance of your computer, right? So a lot of instructions that your computer needs, it needs to have access to those instructions like right away. So let's describe that a little bit more. So let's see here. So you have your memory, right? You have your RAM, which is what we described. It can be a 2 GB RAM memory stick, 4 GB memory stick. But you also have what you call cache, right? Cache, like I said, it is a quick form of memory. So it's separate, right, from RAM. And you have 3 levels, right? You have level 1 cache, level 1, level 2, and 3 cache. So there are 3 levels of that, okay? And they are a quick form of memory so that your computer can work faster. Sometimes your computer doesn't have to go back to RAM. It just uses what you find in cache, right? So let's see here if we get a better description of cache. Let me see. I'm not getting a good. Maybe we'll find a better, like more of a description, right? But most of your memory, right, is going to come from your RAM. Most of your memory. But then we have these options for level 1, level 2, and level 3 cache, which is also available, right, for processors. Let's see. Maybe we'll come back to it later if we get a clearer description of cache. Let's see right here. Okay, we'll come back to it in a bit. Okay, let's keep going. Let's see what else we can find here. All right, let's see here. Okay, so let's go to memory now. We'll see. Maybe we'll get to cache later. But we know that just kind of keep that in your mind for 1 second. That cache is a quick form of memory that greatly speeds up the performance of your computer. All right, so we're going to come back to that kind of like definition in a little bit. Okay. So for memory, right, we have right here, it says we have kind of like 2 types of memory, static or dynamic. Okay, memory, static or dynamic. That is your ROM, what is referred to as your ROM, and your RAM. You see right there, ROM and RAM. So ROM stores data permanently. When you talk about your ROM, information there never changes. Like all the instructions to start your computer, which is referred to as the BIOS, right? In the BIOS, right here, the BIOS on your motherboard is stored on a ROM. So the BIOS on your motherboard is stored on a ROM. The information in your BIOS it's permanent. It doesn't change because it needs that information to start up your computer. So that's what it means. Chips store data permanently. Now for the RAM, let's see right here. So look, okay, see what I just said here. So for the ROM, because the ROM is kind of static information, right? It says the disadvantages of ROM are that it's slow compared to RAM, and that you can't ever update it, right? If your ROM is slow or not moving as quickly as you want it to be, then it says you have to pull out the chip and replace it, right? So ROM isn't used as the PC's primary memory source, right? Your primary memory source is the RAM, not the ROM. So the ROM is just used for a little bit of activity. Is somebody asking a question? Okay, I thought I had a question. I thought I heard a question. Okay. So ROM, Anu, let me go to you. So it says right here that ROM, ROM, which is read-only memory, right? It stores data permanently. You can't make changes to their content, right? But RAM, so back to ROM, ROM, read-only memory right here. Read-only memory stores data permanently on your system. And it's not, right there it says ROM is not, it's not a PC's primary memory source. Your computer only has a small amount of ROM, just a small amount. Okay? So, important to kind of make that distinction. Okay, now
I have a question. Am I on?
Sure.
Yeah. Is there another example of a place where ROM is used other than
Where
BIOS?
it's used?
Other than BIOS. Is it only
Okay.
BIOS?
Well, first of all, yeah, I understand. Yeah. Well, it appears to me like it's just used in the BIOS, right? Yeah. And we'll see some information about the BIOS a bit later. That's why it says that a PC has only a very small amount of ROM. Okay. So it's not something that is used a lot, right? It's not something that is used a lot. So right here it says that BIOS chips, right here, BIOS chips are now stored in a newer modified version of ROM up here, right? BIOS chips are stored on the newer modified version of ROM called EEPROM, electronically erasable programmable ROM, which allows the ROM to be updated by using electronic pulses. So it's very limited, very limited functionality. All right. Okay, let's look at this area here. Let's go to RAM, right? RAM is like the main memory in your computer. Right here, actually, let's look at this part here. Right here, this part. Couch, do you see this part here that is highlighted? Can you read that part?
Okay. The more free RAM in the computer, the larger the available workspace. So the more applications and data files you will be able to have open at once. If your system runs slow on RAM, it can use slower virtual memory to compensate.
So what do you think he's talking about there?
If there's a more free RAM in the computer. Is there any more RAM, free RAMs? It is there's a more workspace there, larger available workspace there, and then it could be the more applications and data files you can able to open at once.
All right. So what kind of applications do you have on your computer?
Like
like down here, you have Microsoft Word.
Yes, Word.
Okay.
And PowerPoint.
You have your calculator. You have PowerPoint. You have You have all those different files on your. You have your browser. You go on the internet.
Yeah.
If the more RAM you have, then you can do a lot of those things, right?
Yes.
At the same time.
Yeah.
So, for example, you don't have to shut down Notepad or shut down my browser to allow something else to work. I can go to the internet. I can open up Microsoft Word. I can open up my calculator. I can do all these things at the same time without any problem. So that's what it means there. The more free RAM you have on your computer, then that's what it means by your workspace. You can do more work, right? You can do more work on your computer. Okay. Okay, so right here it says, let's look at this part here.
Sorry, Banjo,
it says,
I have a question.
Sure.
Maybe we'll talk about that right now, but I saw that when it runs low RAM, it uses virtual memory. What is that virtual memory about?
That's what I was going to just talk about now. You took the words out of my mouth. So right here it says that if your computer, sorry, let me take this up. So write this line, just to highlight this line so we can see what I'm talking about. Okay, if your system runs low on RAM, it can use slower virtual memory to compensate. Okay, so what is virtual? That's what Alex just asked. What is virtual memory? Okay, so let me show you what virtual memory is. So on your computer, right, go to your control panel. So you say, actually not your control panel, open up your files. So click on your yellow folder, bottom of your screen. Click on your yellow folder, right? And then look for this PC right here, this PC. Right click on this PC and go to Properties. Okay. When you get to Properties, you're actually looking for Advanced System Settings. Any luck finding that? Banjo? Let me do that again.
Yes.
Go to this PC. Right click, go to Properties. And then you're going to look for Advanced System Settings. Alex, do you see that? Then it brings you to this. It brings you to this window, System Properties.
I found it.
Okay. So when you come to System Properties, right? You have computer name, hardware, advanced, system, remote. The tabs up here. Go to the Advanced tab and click on Settings, Performance Settings. Right? Now, when you get to Performance Settings, click on Advanced. So you have a long way to get there. It's like you have to take the train to get there. A lot of different stops along the way. So let's do that again. So go to this PC, right click and go to Advanced System Settings. Are you guys hearing me?
Yes.
Okay. So go to System Properties under the Advanced tab, go to Settings, and then you go to Advanced again. Now you're going to see right here, this is your virtual memory. It says a paging file is an area on the hard disk that Windows uses as if it were RAM. So on your computer, besides your RAM, there's a kind of a reserved spot on your computer. We can say kind of like a backup memory, right? It's kind of like a backup memory that Windows uses on your computer. So make sure you don't change anything here. Windows sets the number automatically, right? It sets the number automatically. Ling, are you able to see this?
Yeah.
Okay. So Windows sets the number automatically. So don't go and change it. Like, oh, I want it to be more. Like, I'm going to change it to like 50,000. Don't do that. Your computer is going to...
So on my computer, it says total paging file size for all drives, 2,304 megabytes.
Yes.
It's like space. It's like space on a disk.
It is also memory. Like what it says here is a paging file is an area of the hard disk that Windows uses as if it were RAM. So it's kind of like backup memory. Like, you know, if you have no memory on your computer, like worst case scenario, it will kind of go and tap into this, Sam. It will go and tap into it. You know, it's like, you know, when you save, you know, something for the rainy day, rainy day fund.
Right.
Yeah. So maybe you say that's, but don't touch it. I mean, the number is going to be different, the size. Mine is different, my size. So the recommendation is don't go and change it because you're going to mess up everything. Just let Windows determines the size automatically.
Mm-hmm.
All right. So, but that's where it is. It's kind of like a long journey to get there, but that's how you find it. And it's also described for us in the book here, right here, accessing your computer's RAM and virtual memory. So, of course, the RAM itself, if you go to your control panel, you find the RAM. Actually, what am I doing? The same way we just found that if you go to this PC, I think it's easier to get there. This PC properties, right here is my RAM. So my RAM here is 12 gigabytes installed RAM. And then you have the backup virtual memory. So Alex, that's what it's referring to here as, where do we see that? If your system runs slow on RAM, it can use the slower virtual memory. But I think that the virtual memory is slower. So it's not going to be as, you know, it's not going to perform like the regular RAM, but at least it's an option for your computer. Okay. Yeah, and that's what he also explains here. He says many computers use a lot of RAM, right? And it says to prevent the user from being denied an activity because of a lack of available memory, the operating system uses virtual memory to take up the slack. So when your computer is extra busy doing a lot of stuff, it might have to go into your virtual memory, right, to allow you to continue to work. So it's kind of like a backup memory that's available. Okay, let's move on.
I'm sorry, I have another question.
Sure.
Is, when you use another hard disk, like an external hard disk, does the Windows consider a part of that one too, or just the main hard disk?
You mean when you use an external device?
Yeah.
That is it. Oh, okay. When you use an external device, is it part of the memory of the computer? Is that what you're asking?
Maybe the kind of memory that we use like on USB or something like that.
Oh, well, that's Alex. That's we're going to come to that, but that's different from RAM. RAM is basically what allows your computer to do a lot of stuff that you do. Where you save your files, it's a different matter. We're going to come to that. So on a flash drive, on a hard drive, external drive, we're going to talk about that. That's not RAM. RAM is what your computer needs to be able to do whatever your computer needs to do, not saving files.
Mm-hmm.
Right?
Yeah,
Not about saving files.
Actually about if I use the external memory, the external hard drive, does the Windows consider that one too? Like, does it take a part of that one as a virtual memory?
No.
No.
Virtual RAM and virtual memory are things that are installed in your computer. So I don't think that if you use an external device that it I don't think it affects that or changes that at all. If I'm getting your question.
Yeah, that's what I was.
Okay.
Thank you.
All right. So now, if you remember what we said about, excuse me, the memory bus. Memory bus is we used an example the other day of like lanes on the highway, right? Lanes on the highway. So let's see, we found a few images here. Okay, so expressway lanes. So okay, so we use this picture, right, to look at if you have the more lanes you have on the on the highway, on the expressway, then the cars can go faster, right? Everything can go faster. But if you have just a few, you have just a small lane, just two lanes, there's gonna be a lot of traffic, right? So when we go back here to this document, talk about the memory bus, right? The memory bus are, where is it? The lines you see on your motherboard. So let's see that again. Motherboard, memory, where is it? Yep, memory bus lines. All right, so here's an example that we looked at. So something like this, right? In your motherboard, you're going to see lines. These lines are actually, these lines do something. All these lines you see here, they help to carry data back and forth, instructions back and forth, right? Between all the different components on your motherboard. So all these lines, right, they move at a certain speed, right? The data moves at a certain speed on these lines. So that's what it's referring to here, the memory bus speeds. Okay, so right here it says memory has a bus width that determines how many columns are in each row of storage. How many columns are in each row of storage? All right. If you look right here also, right here, it says the memory bus has a speed. It determines how quickly data will travel on the path, right? Memory on modern PCs is synchronized with the system bus, which in turn is controlled by the system timer on the motherboard, right? The system timer. The system timer is what controls the speed. So here's the system timer right here. The system timer determines the speed at which the data enters the processor, right? So the processor, remember, here is your processor right here. Where is it? Here's your processor right here. The processor has to receive that information and then send it out to all the other components of the computer. So the speed of receiving that information and sending it back is what we're talking about here. It says the system timer determines the speed at which data enters the processor. Memory, so let's look down here. Let me get rid of this here. Right here. May, are you there? May, can you read this part? May, can you read this part?
The system timer determines the speed at which data enters the process. Memory that operates at the same speed as the front side bus is called single data rate, SDR.
And it has a very long word there. Synchronous dynamic random access memory. I'm sure you're like, what is this? How do I say this? How do I pronounce this, right, May?
Yeah.
Yeah, just think of SDR or SDRAM for short.
Okay, good.
So it says that memory that operates at the same speed, right? So the system timer determines the speed at which data enters processor. So basically, SDR and SDRM, right, are different speeds, right? The different data speeds on your computer, right? Different transfer rates. It's like having a slow car and a very fast car, something like that, right? Like when we look at this picture, some of these cars might be very slow, some might be very fast. It's kind of like what he's talking about. Some of the lines here might be faster than some of the other lines when you're delivering data. That's basically the idea here. So right here, if you look at this area, since this DDR1, it makes, let's see, this DDR1 makes higher transfer rates achievable, right? DDR1. So it's a kind of a system timer, but DDR1 makes higher transfer rates achievable, right? Then it also refers to, it controls the timing of the electrical data and clock signals so that data can be double pumped. So all you need to remember is this DDR1, which is double data rate. DDR, double data rate 1. Double data rate 1 makes transfer rates, higher transfer rates achievable. And then you have DDR1 and DDR2. And what they do is they enable right here. Enables greater throughput and requires lower power. So look at it. Let me try to break this down. Let me take this out here. So DDR1, it makes higher transfer rates achievable. Now, after DDR1, you have DDR2. So the difference, let's look at the difference here. The difference is DDR2 requires lower power, right? Lower power by running the internal clock at half speed. So DDR1, right, makes things pretty fast, but DDR2 uses less power. Right, so a lot of technical definitions. I'm sure you're feeling like, why am I in this class? Right? A lot of technical definitions that we need to kind of remember when we're getting ready for the exam. But don't worry about it. We're going to work together to help you guys.
Can we sum up by just going over all of that information and just sum it up? what are we talking about? We're talking about electrical transfers between the CPU and the motherboard? Oh, the CPU?
Yeah. So this is all talking, no, this part is talking about the memory bus, right? The memory bus.
Oh, okay.
So the memory bus, right? The memory bus is basically, when you say the bus lanes, right? On the motherboard, you have all these green lines. And all these green lines, they transport information. Kind of like this picture here. It's like those lines here with all these cars going back and forth on the highway, delivering data. So the speed, we're looking at the speed at which they travel. The speed, right, on those different lanes on your motherboard. So right here, DDR1 and DDR2 are basically two types of transfer rates, or should I say transfer speed.
Okay.
Now, DDR1 says it has a very high transfer, right? But DDR2 has an equally high transfer, but says it requires, what does it say here? Lower power. So it's probably more efficient, right? More efficient than, so DDR2 is more efficient than DDR1.
Okay.
It's kind of like when you have maybe, like when you have, let me ask Arch. Arch, are you there?
Yes.
So when it's like talking about DDR1 and DDR2, it's kind of like when you're trying to be more efficient, right? So like you talk about a car that runs on gas, on fuel, and a car that runs on electricity, right? Like your electrical vehicles. Now you say that the electrical vehicles are more efficient, right?
Yeah.
Maybe, I don't know if that's a good example of efficiency, but that's what it's trying to tell us here, that in this case, it uses lower power. Or actually, we have some, I think I got a good example here. Efficient power bulbs. Why do I keep coming to this page here? Oh, I didn't type. Okay. All right. So now, I mean, we all use bulbs at home, right?
Yes.
And sometimes when you read the information, it tells you that some of these bulbs are more efficient than the other. So the one on, I mean, I don't know if you have this at home, Arch, but I have
Yes,
this
yes.
and I have this.
Okay.
And so they tell you that the one on the left is like it burns up so much more energy,
Okay.
right, compared to this one. And this one and the one on the right lasts longer.
Yeah.
It doesn't burn up so much energy. So when you talk about efficiency, right, you have two different, similar products, but one of it lasts longer and uses less power. So if you see your bill at the end of the month and you have this kind of, I mean, it might be a bit more expensive, the one on the right, but when you look at your bill in terms of your power consumption, it looks like the bulb on the right, gives you more efficiency. So it's giving you light, but it's not using as much power. Does that make sense to you, Arch?
Yes.
So that's kind of like, Sam, right? Something we can relate to in terms of efficiency.
Okay. All right.
All right. So that's what it means here with this DDR1 and DDR2. DDR2, it's all about memory bus speeds that is transferring data back and forth on your computer with all the instructions, but DDR2 is more efficient.
Okay.
All right. So let's just keep it at that.
Excuse me, Banjo.
So we talked about this already. Sure, go ahead, Arch.
I have one doubt about ROM. Can you give me one example of ROM? It's a permanent storage, but um, I have a doubt, like is timer or clock is an example of ROM, date and time.
Oh, you mean RO? Are you talking about where is it now?
Read-only memory.
Wait, are you talking about RAM? Talking about RAM here?
No, I am talking
ROM,
about
ROM.
ROM. Yeah.
Where is it? Let's go back up there.
Yeah, here.
Oh, you mean? Let me get this out of here. So you mean ROM here?
Yeah.
So you want an example of ROM?
Yeah.
Well, so what it tells us here is the best example we have is right here. Let me get this out of the way here. It says the BIOS on your motherboard is stored on a ROM chip, right? Now, BIOS is, give me 1 second here. Let me find some more information about your BIOS. All right, so your BIOS, we're going to come there in a bit, but let me just, since you asked about it now. So let's see what it says here about your BIOS. Okay, so right here, if you look here, all right, let me use that one over there. Just want to highlight it so we see what we're looking at here. Why is it not highlighting? Come on, give me a highlight. Okay, let me do that again. All right, so right here it says, aside from the processor, right? We looked at the processor already, the chip and all that. You have another chip. The most important chip on the motherboard is the BIOS chip. So you have your CPU chip, right? And now you have the BIOS chip. This special memory chip contains the BIOS system software. And what does it do? It boots the system and initiates the memory and hard drive to allow the operating system to start. So the BIOS is basically what is responsible when you start up your computer. You know, your computer is going to go through, all that, Windows and reading everything and hardware and memory and, trying to start. Everything that is involved in your computer booting up, or when you restart, or when you start the computer, that is the job of the BIOS system. And the BIOS system is stored on, what does it say here? On the ROM chip, right? So we have two chips here. You have your ROM chip, and you have your processor CPU chip, right? So right here it tells us where it is. It says the BIOS chip is easily identified. Let's see if it tells us where it is. Let's see. So, okay, so we have something made by FinTech. So figure 1.2 gives you an idea of what a BIOS chip might look like. This was made by FinTech. So right here, that's your BIOS chip, right? So it's different from your CPU chip. And the job of this guy here is to boot up your computer so that you can start to use it. You understand? So that makes so that's basically an example of what uses the ROM chip. The ROM chip is used by the BIOS system software to boot the system, to boot it up. Make sense, Art?
Yeah. Yes. Thank you.
So that's a great question there, and that's what that is there, and that's what it's used for. Okay, let's go back up here a little bit. I think we saw some of this already. We got to go back down, 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 down. Okay, so right here, so we've looked at the RAM already, the physical, your RAM. Basically, the RAM, like I said, it has, that's what it looks like. It might have different sizes. This one here is a 2 gigabyte RAM. You can see that up here, 2 gigabyte RAM, and you can install it on your, it's installed. Art, so where do we install this? In the motherboard, what's it called?
ID.
We talked about it, right?
SAT ID.
Yeah, where do we install this memory sticks? If you want to insert it in your motherboard, you put it where?
Like ID, like slot.
Slot.
In the slot. What's the slot called?
RAM slot.
Memory slot.
No, please. Yeah.
Well, yeah, it's a memory slot, but there's a name for it, right? There's a name for it's called this slot here. This slot you see here. Where is it? 1 second. Let me go back up. Okay, wait a minute. Okay, so when we looked at PCI, right? Let's go back there again.
Okay, is it expansion slot?
Yes,
Very
yes,
correct.
yes, yes, yes.
Okay.
Expansion slots. This guy's here, right? Expansion slots. And you can see right here, that's an example of your memory in your expansion slot. Right here. So you have the AGP slot, this one here, and you have the PCI slot, right? So they're called expansion slots, right? Expansion slots. And PCI, again, stands for Peripheral Component Interconnect, PCI slots. Okay. Well, now, of course, the current one we have is PCIe, right? PCIe expansion slots, right there. I remember we looked at this picture to see the different types of pins, right? By 16, by 1, so this by 16, by 1, by 1. All right, so yeah, so you install them in your expansion slots, okay? All right. So let's go back. So these are your memory sticks, and that's where you install them in your expansion slots. Okay. All right, let's move on here. So right here it says if you want to know the type of installed RAM in your computer, like I said, well, I saw mine here, right? The installed RAM is 12 gigabytes for what I have here, right? So that's how you find, it says that's where you find the RAM on your system. Okay. Now, of course, if you're able to, okay, well, you asked us a question here about, look at that, about DIMM and SODIMM, right? DIMM and SODIMM. So basically, what we should remember is most laptops use SODIMM and most PCs use DIMM. They're just different types of RAM. Okay? Different types of RAM. So SODIMM is for laptops and the DIMM is used by PCs. All right, and we can see that that information up here about DIMMs and SODIMMs. So right here, let's see. So you have some details here, basically about the DIMM and SODIMM. But I guess the important thing to note, if the kind of question that you might see is, of course, you got to read this part here, right? But just to move along, the DIMMs refers to, let's see, right here. Let's look at this here. It says different types of DIMMs and SODIMMs may be similar or even identical in overall size and shape, and may even have the same number of pins. Now the pins, right? This pins here, you see this pins here, right here on the edge? That's what I believe it refers to right here, the pins. DDR4 has 288 pins, but it has the same length as the DDR2 and DDR3. So it refers to these pins here, these pins. Anjuman, you see these pins here?
Yes.
The pins on the edge? Yeah. So those are the pins. Now see what it says here. It says notice how they basically look the same, but the key notches. So these notches here are different. So this is the notch, this is the notch, this is the notch, and this is the notch. Right? So you have, you know, for so the bottom one is for the laptop. So this one here is going to be the laptop, and these two up here in desktops. Right? So that's what it refers to. So this bottom one, you can see the name, right? Right here, this is a SODIMM, right here. And that's for your laptop. So maybe one day, if you work in a computer company and your job is to, I don't know, help them make this kind of stuff, right? For laptops or desktops, you have an idea of what they're talking about. Like, hey, Anjuman, can you bring us 5 SODIMMs? You're there, okay, this is for the laptop. I'm going to go look for this one and not this one here, right? So, so it's referring to, yeah, so that's what it means there. It says most laptops use SODIMM and desktops use DIMM. So the different sizes and characteristics of your memory sticks, of your RAM. All right. So let's go on a little bit here. It says storage and expansion devices. Alex, this is maybe part of what you're talking about here. So far, we've talked about motherboards, processors, and RAM. Okay? Now let's look at hard drives. Hard drive. So here's a hard drive that you can find on your computer. Well, you might not see this part. Let's go here and say PC hard drive. All right, so your computer, if you're able to see your hard drive in your computer, it might look something like that, or it's got a good picture here. Yeah, something like this is your hard drive on your computer, right? A hard drive. It's inside your computer. Okay, so let's see. Now inside this case, like right here, you have what looks like a CD. You have like a CD, right? Looks like a CD, a disc. It's a disc right here. A disc, like a compact disc. Or actually it's referred to as a hard disk drive, HDD. And now compared to your memory and all that stuff, your hard drive is used for what? Banjo? What's your hard drive used for? What's it say here?
For storage and quick access?
Permanent storage, right? Permanent storage. If I save this file, right? If I save this file on my computer and I shut down my computer, Banjo, Can I find that file?
Yes.
Okay, how about right now, I have my browser open, I have Zoom open. If I shut down my computer and I restart it, would I see all this Zoom and all these browsers open?
No, I don't think so. No.
That's you see, that's one of the differences between your RAM and your hard drive. Your RAM helps you work while you're working right now. It keeps everything in place, but it doesn't store it permanently, right? It doesn't store it permanently. When you restart your computer, one or two things might open up how it was, but generally everything is going to just close, right?
Yes.
But your hard disk, whatever you save on your hard disk, as long as you saved it there, it's always going to be there. Files and, you know, all that kind of stuff. Okay.
Okay. I have
So right here,
okay.
Sure, go ahead.
I say about a hard disk and RAM, permanent memory. Hard disk, when I put up this computer or PC, only this time I can see this memory. When I off this PC, then it's out. If you say about this, a hard disk, CD, about CD, compact disk.
So you're talking about no. What a hard drive,
hard
right?
drive, yes.
A hard drive is not the same thing as a CD.
Oh, yeah, yes.
A hard drive. Okay, let me show you a YouTube video here. It'll give us a good idea. So here is a picture of a hard drive, but let me give us something a bit better. This is a CD.
Yes.
Right? This is a CD. So
yes.
We're not talking about so it's a bit different, right? Your CD, right, used for, you know, music or pictures or something like that, right?
Yes.
It's different from your hard drive. So here's what the hard drive let me see. Let's go to YouTube here. Hard drive. Okay, so let's see hard drive disk is what you might see. Okay, so now inside your hard drive, well, this is a good picture actually. Okay, so let's look at this one here. Okay, so you see, so look at this here. Yes. So she's going to, so that's the hard drive, right? That's the hard drive. This hard drive is installed inside your laptop or your computer, okay?
Okay.
So now she's going to open up the hard drive. When she opens up the hard drive, inside the hard drive, it looks like a CD, but it's not a CD, right?
Right.
So she's going to open it up, so you see that?
Yes.
So it's kind of like a CD, but it's not the CD that's used for music. So it's a bit confusing, right? But see what happens there.
It's installed side of PC.
Exactly. Or inside a PC or inside a laptop.
Yes.
So let's just see. So she's just trying to explain all the different parts, right, of that system there when it runs. So see what happens there. So it spins, right? When it's running, it's spinning and spinning and spinning, continuously spinning. That little device there helps it spin. Let me just show us a little bit more here. Let me see if I can find something else here. Let's just go into a bit of detail. All right, so maybe that helps. Let's see if we can see another quick example here. Ads. All right, so that's inside again, right? That's kind of like how it looks like, right? There are different disks inside. It might be different layers of disk.
Yes.
And it's just constantly processing information, constantly. Okay, so let's go out of this one here. So that's what I was referring to here, right? It looks like, you know, that's this picture we see here, right? It has different, they look like disks, but they're not CDs, right? They're all installed in your hard drive. Make sense?
Yes.
Okay. So their job is to save. So the job is to, it says right here, let me check this out. Right here, if you see this information, it says as a hard disk operates, the platters, those round objects that look like CDs, they rotate at a very high speed. They keep moving around. They read and write, basically saving information, right? So they're constantly going round and round and round. It's kind of like, let me show you this too. This might maybe an old, let's go here, see. Okay, if you remember, I don't know if you guys ever, you know, this is like a long time ago, but you know, when you have this record players, right, like a long time ago. Has anybody seen this before, ever? It's very old.
Yeah, we have seen.
I've seen those in movies.
It's a gramophone.
Yeah, in movies, right? On YouTube.
I have seen baby cat.
Exactly.
Yes.
So your hard drive kind of looks like that, right? Where the CD is constantly turning, but when it's turning, it's not playing music, it's just saving your information, right? It's saving your information. So if that helps, from a very long time ago, it's saving your information on your computer. So sort of like what this lady was trying to show us here in this YouTube, the other one we saw, right, in the YouTube clip. This one here. Yeah, so something like that, right, is what happens. It turns and turns and turns. Okay, makes sense? Okay. So besides your hard drive, of course, we had, you know, things like floppy disks, right? Floppy disk are, you guys might remember floppy disk, maybe. Floppy disk. Anybody ever saw floppy disk before?
Yeah, we have seen.
Yes.
Yes.
May, have you seen a floppy disk before?
Yes.
Okay. So in fact, so if you look at this floppy disk, right, let me show you something that you may not have noticed, May. So look at this. When I go to Microsoft Word and I want to, let's see, I want to save a file. You see this icon here for saving?
Yes.
Yes, sir.
You guys see
Shows,
that? It's the same shape as the floppy disk, if you notice that, right? This save button here. So that's where they got it from.
Yeah.
Yes.
Did you guys know that before?
Yes.
That's where you got it from. The shape is, you know, the save button is from here. So it's never changed. It's always been the same. But it refers to the floppy disk. So the floppy disk was an option for you to save files, right? But the floppy disk had very little space. You couldn't really save a lot compared to what you can do right now. So it says right here, the most you could save on the floppy disk was, excuse me, Couch, what does it say here? How much could you save on a floppy disk? 1.44 megabytes only. Well, how much can you save on a flash drive right now? On a hard drive?
Then there's 32, 80 GB, 32 GB. Then like
let's see my hard drive here. You can see my C drive. Look at my C drive. 475 gigabytes, right? 475 gigabytes. Compare that to 144 megabytes. Like a very tiny baby and an old man. Okay. So when you look at your hard drive, right, your hard drive might have some characteristics here. Okay, and we tried to look at this the other day, right? The different sizes. So let's see, did we get it right? Let's see that picture we had. So we tried to use this when we did it the other day, right? So 1 bit is 8 bits is 1 byte. So we got that right. 8 bits, 1 byte.
Yes.
1,000 kilobytes is 1 megabyte. I think we got everything right except when we got to petabyte. So 1,000 petabytes is 1 exabyte. So right here, so this should be EX. And then 1,000 exabytes. So let's take this out. So 1,000 exabytes is 1 ZB. ZB. ZB, zettabyte. Zettabyte. Okay, so let's look at this here. So it says that for 1 gigabyte, a full-length audio CD is about 800 megabytes. If you have a movie, right? A movie, you want to watch a movie, a 2-hour movie is about 4 gigabytes. So a 2-hour DVD movie is about 4 gigabytes. All right. How about exabytes right here? So YouTube, all the movies, right? All the video clips that are on YouTube, well, they're saying that it's about 1 exabyte. That's a lot of data. Arch, can you hear me?
Yes. Yes, Professor.
So all the info you have on YouTube might be that much. Now, how about zettabyte? Zettabyte says the U.S. National Agency, NASA, right, or the NSA, they have about 5 zettabytes of data. That's a lot of data, okay? So you might wonder in your mind, well, who needs all this data? Well, when you have large organizations or companies. Okay, now we didn't talk about, look at this part, we didn't talk about yottabytes. You know, I mentioned that to you, yottabytes. And I think the highest level is going to be, so you have YOTTABYTES, and then you also have BONTABYTES. So I think those are the 2 like real big ones. Well, we didn't talk about zettabytes. So zettabytes is also there, right? Zettabytes, ZEDATTBYTES, right? Zettabytes, yottabytes, bondabytes. So there you go. Okay, so for your all right, so let's see. So you're going to see things like RPMs. right, for your hard drives, when the hard drives spin, right, when the hard drives are spinning around, like this picture we looked at, right? When your hard drive is spinning around, revolutions per minute, RPMs. So you can have 5,400 right up to 15,000 RPMs. Okay? So right here, it says a higher rotation per minute means that your data moves more quickly. But everything uses a lot of heat and your battery. So it depends on the configuration of your computer. So RPMs, revolutions, right? That is when it turns, like when the Earth revolves around the sun, turning revolutions. Okay. Okay, so that's that. That's your RPMs there. The rate of the different spin rates of your hard drive. Okay, inside the hard drive. In fact, if you listen, if you put your ears close to your laptop, you might hear it going, making some sound, right? Have you heard the sound, Andrew man? Like if you listen real close to your laptop, you're gonna hear it spinning. Yeah. It's doing a lot of work. Okay. So now let's talk about the connections for the laptop, the different connections. You have the data and the power connections. We talked about this the other day, right? The different connections on the laptop. So you have your, right here says, let's see. All right, so you have the data cables that connect to your hard drive. So this one here is the PATA connection, and the bottom one is the SATA connection. All right, so when you take a look at it, why do I have all this? Yeah. When you take a look at it, you know the difference. This is like the newer one, right? The SATA cable is like the newer connection. And the PATA is kind of like a little bit older. So if you see this hard drives here, right? The bottom one here, right? The bottom one, no, not the bottom one. Yeah. Yeah, the bottom one here is your SATA, and the top one here is your PATA IDE right here. So it's just how it's connected with the cables here. Okay. All right, let's see what else we have here. So here it talks about solid state drives, right? It says, unlike conventional hard drives, a SSD has no moving parts, but uses the same solid state memory, like a hard drive, but it has no moving parts. So your hard drive, just like we just saw, your regular hard drive, it moves, right? It kind of spins, but it says that a SSD does not do that, right? Does not do that. So here are advantages you might find of an SSD. For an SSD drive, solid state drive, it has this benefit here. It's silent, it's more quiet, uses less power, right? The disadvantages of your SSD is more expensive. It says your SSDs are more expensive, right? More expensive. And right here it says a lack of longevity. That is, maybe it doesn't last very well. Look at this here. It says, to summarize, SSDs are faster and produce less heat, but are generally more expensive, right? More expensive. So, you have to make a decision on what you want to use. but I think the options are right there for you. Okay, optical drives is what Anjuman just asked me about. Optical drives are CDs, right? CDs, DVDs. Where is it? Where are my CDs? So CDs, optical drives. Optical drives. All right, so here are optical drives. You can you use them for music or pictures on your computer, right? Optical drives. Don't confuse this with your hard drive. It's not the same thing, right? Not the same thing. So these are optical drives that you can find used on your, music and all that stuff.
Regard to the pen drive, like pen drive.
Yeah, so you can put this in the drive, right? You can put this in the drive in your laptop, or you put this in the drive in your computer. All right. Okay, let's keep going here. So those are all your optical drives are: CDs, DVDs. So your BDs are your Blu-ray Disk, right? So compact disc.
What is the BD?
Ling, question? What's a BD?
Yes.
Right here. That's your BD right there.
Oh.
Right here. Blu-ray Disk. So Blu-ray Disk, digital video disc, or compact disc, right? Compact disc, right there. So that's what we have there. And then of course you have when you look at the CD or DVD, you're gonna see things like this. So Ling, do you know what this is? What does this refer to? What is, if you see an RW, what does that mean? Do you know? Ling? Ling, you're muted.
Oh, sorry.
So what's RW?
I don't know.
Or anybody knows what RW is?
Read, write.
Rewritable.
For reading and writing.
Okay. All right. So yeah. So you're right. RW means you can record, right? You can record, or you can write on it. But RW means that you can erase and rewrite.
Oh.
So plus RW means that you can erase stuff from that DVD and put new things there.
3 minutes, Chinna.
Got it. Thank you.
All right, so that's what that is. RW is you can write on it right here. Right here. Okay, look at what it says here. Actually, it says R minus R is recordable. That is, you can record. Minus RW is rewritable. But then the plus RW means that, okay, see right here, you can re-record. So that's what that is there. So a few things for you guys to go over to know what. So when you look at these different options here, I mean, like there's so many different options. Optical disc and their capacities, right? So you might have, 4.7 gigabytes, 8.5 gigabytes, 8.5 gigabytes. So it might be a right here. It might be a, a DVD, recordable. Right here it says DL is dual layer, and SS is single-sided, right? So single-sided, double-sided, right? So you can record on one side, on two sides. They all have different specifications, right? So right here is a DVD recordable single side dual layer. So when you look at this this descriptions here, gives you an idea of what you can do. So right here, it says a double-sided single-layer DVD will give you more storage than a single-sided dual-layer DVD, right? So a double-sided single-layer DVD will give you more storage space, right, than a single-layer dual DVD. All right, so we're going to end it right now. We're basically almost at the end of this chapter here, but we're just going to leave that for now. Let's see, what else do we have? Just a few more things. Yeah, we're almost at the summary. So just a few more things to cover for that particular chapter 1. It's just talking about the power outlets, the different power outlets for your computer, like power supply, when you give power to your computer, and also your network card. So we can review this. We can review this on at the next class. Okay.
Okay.
Thank you.
So what I want you guys to do is I want you to go to, like, right here at the bottom. So let me show you here, because so did you get the book yet? Did anybody get the textbook?
Yes. Yes, we got it.
No, I didn't.
No.
Someone got it.
Well,
No, I didn't.
you have to go to Quincy College to get it. You have to go to Quincy College to get it.
I go later.
All right, so right here, let me just get something. Give me 1 second here. Why are you doing to me anything? Okay, so if you look at the summary anyway, the summary in chapter 1, it looks like my